quotient rule allows us to take the derivative of a quotient. So before, there was no way we could have handled taking the derivative of 1 over x minus 2. We would have been fine if the denominator was a single term, but since it's an x minus 2, we had no way right now of handling this problem. The quotient rule allows us to find the derivative of a problem like this. So the quotient rule says, if you're given a quotient, t of x over b of x, the derivative of t of x over b of x is b of x times the derivative of t of x minus t of x times the derivative of b of x all over b of x squared. So in words, it's the bottom times the derivative of the top minus is really important. Make sure you're memorizing these correctly. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So I typically write it as the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So let's go ahead and find the derivative of the next few examples. In our case, our top function is 1 and our bottom function is x minus 2. The derivative of our top function, well, the derivative of 1, which is a constant, is 0. And the derivative of the bottom function, well, the derivative of x minus 2, the derivative of x is 1. The derivative of negative 2 is 0, so I don't need to write plus 0. So let's go ahead and find the derivative. F prime of x is going to equal, remember our formula says, it's going to be the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So plugging in what we know, we get x minus 2 times 0 minus 1 times 1. That's all over x minus 2 squared. Now if we simplify here, anything times 0 is 0, and so we end up with negative 1 times 1, or just negative 1, over x minus 2 squared. So the derivative of 1 over x minus 2 is negative 1 over x minus 2 squared. Let's try number 5. Same thing, we label. So my top function is x squared minus 4, and my bottom function is x plus 1. The derivative of the top, well, the derivative of x squared is 2x. The derivative of 4 is 0. We don't need to write that. And the derivative of the bottom, well, the derivative of x is 1, and the derivative of 1 is 0, and we don't need to write that. So this is going to follow the formula. F prime of x is going to equal the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So plugging in, we get x plus 1 times 2x minus, the top is x squared minus 4 times 1 all over x plus 1 squared. So let's go ahead and distribute the numerator and combine like terms. F prime of x is going to equal, if we distribute, 2x times x is 2x squared, 2x times 1 is plus 2x, and then 1 times this is going to be just x squared minus 4, but make sure you distribute your negative. So we have negative x squared plus 4. and it's still all over x plus 1 squared. Last and final step is just to combine like terms. So 2x squared minus x squared is just going to be x squared plus 2x plus 4. So the derivative of x squared minus 4 over x plus 1 is x squared plus 2x plus 4 all over x plus 1 squared. Let's go for our next one. Same thing as before. Let's label. The top is going to be 2 natural log of x. The bottom is going to equal x. The derivative of the top, well, 2 is a constant multiplier, it multiplies along. The derivative of the natural log of x is the derivative of x. Well, the derivative of x is 1 over x. So this is the same as 2 over x. And the derivative of the bottom, well, the derivative of x is 1. So f prime of x is going to equal here the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And here, the only thing I can do to clean this up is if I multiply an x times 2 over x, my x's are going to cancel. So this is just going to be 2 minus, and then 1 times anything is itself. So 2 minus 2 natural log of x all over x squared. So the derivative of 2 natural log of x over x is 2 minus 2 natural log of x all over x squared. Number 7, the derivative of e to the x over e to the x plus 1. Again, we're just following our formula. Identify the top, identify the bottom. Find the derivative of the top. Well, the derivative of e to the x is e to the x times the derivative of x, which is 1. So t prime is going to be e to the x. The derivative of e to the x plus 1, well, the derivative of e to the x is e to the x times the derivative of x, which is 1. The derivative of 1 is 0. You don't need to write that. And e to the x times 1 is just equal to e to the x. So the derivative is going to equal f prime of x is equal to the bottom, e to the x plus 1, times the derivative of the top, e to the x, minus the top times the derivative of the bottom, all over the bottom squared. So the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. Okay, so now let's see what we could do to clean this up. We'll notice that from these two terms and from these two terms, from here and from here, we can factor out an e to the x. So if we factor out an e to the x, we would get, well, this e to the x would go away, and it's just e to the x plus 1 minus one of these e to the x's would go away, and I'm left with an e to the x. And then we notice that inside these brackets, my e to the x's are just going to cancel. Therefore, f prime of x is going to equal, well, e to the x times 1, because the only thing that's going to be left inside the parentheses is a 1, it's just going to be e to the x all over e to the x plus 1 squared. So we end up with e to the x all over e to the x plus 1 squared.